Okay, so we want to look at the third problem in the homework, 1011. It's talking about battery life. So it says an important feature of tablets is battery life, the number of hours before the battery needs to be recharged. The file tablets contains the battery life of 12 Wi-Fi only and 7 3G, 4G Wi-Fi, 9 through 12-inch tablets. Okay. And it starts off with part A, assuming the population variances from both tablets are equal, is there evidence of a difference in the mean battery lifetime? Okay, and we know because this problem is in section 1 that we're looking at the difference of two independent populations, the difference in the mean for two independent populations. So let's go ahead and grab this data set. So this was tablets. There we go. Okay. We'll select all and we'll cut. I'm going to leave a little room here because I want to compute some statistics off to the side. Okay. And I'm going to add a little counter here also, just to make life easy on ourselves. And just drag this down like so. Okay. You can also see that this can't possibly be a paired t-test simply because of the fact that we don't have equal sample sizes in this problem. So it has to be an unpaired t-test. And we'll go ahead and compute our test statistics. Okay. Now you have to be careful. You can't just drag this down because notice that I have empty cells here, and it will actually incorporate those when we compute the average. So we have to compute the averages and the standard deviation separately. Okay, here we go. And the same comment applies for the sample standard deviation. We have to compute them separately because we don't have equal sample sizes. Okay, so here n is equal to 12, and here n is equal to 7. And now we're ready. Okay, so we're going to start computing the pooled sample standard deviation. I could just call it SD. Most people abbreviate standard deviation SD. So the first thing I'm going to do is I'm going to compute, I already have the sample standard deviations. I'm going to compute the contribution to the numerator and the denominator. And then just take the square root of the ratio. Okay, so remember this is going to be the standard deviation from each sample squared times the sample size minus 1. Now this one I can drag across because the values are in the same corresponding cells, so I can do that. And of course my numerator is just going to be 17, but I'll go ahead and compute it out. Okay, and now we're ready to compute the pooled sample standard deviation. So it's just going to be a square root, and I'm going to have two terms in the numerator, so I'm going to have to put a nested parentheses here. And by the way, you can compute this all at the same time. I'm being a little bit careful here in how I do things. Again, the reason why I like to compute this is I like to make sure that the standard deviation from the pooled sample standard deviation between that of the two samples, that it is. If it isn't, you know for a fact you made a mistake, so you have to go back and redo this formula. And the last thing I'm going to do is I'm going to compute the standard deviation of x bar. So, and actually I want to be careful, it's x1 bar minus x2 bar. So this is a standard deviation of my estimator. Okay? And so we remember the formula is equal to the square root of, oops, okay, and it's going to be this squared divided by the sample size plus the same number squared divided by the other sample size. Okay. And again, we see that this number is less than each of the standard deviations from the sample, so that's good. Okay, now we're ready to start our hypothesis test, and really the structure is very much the same. I'm just going to take the same template actually that I used before, and I'm just going to bring it over. Okay, so for part A, we're doing a hypothesis test at alpha equal to 0.05 for a difference. And of course, that was exactly the same problem that we just got through in 9 doing. Okay. Oh, I need to go back because of the way I copied it. And I'm going to paste it as values. I don't want to paste the formulas. Okay. So the first part is the same. I need to compute the test statistic though, right? So again, this is going to be the percentile for this is going to be the percentile for the I'm sorry, the test statistic is just going to be x1 bar minus x2 bar minus 0 divided by the standard deviation of x1 bar over x2 bar. Yeah, I'm thinking of the p-value. I'm getting ahead of myself. Okay, so it's just x1 bar minus x2 bar divided by this. And so we get we get a pretty small test statistic, okay? So now we can go ahead and we can compute the p-value. It's 2 tailed, so I have to multiply by 2, and the test statistic is negative. So I'm not going to have to worry about taking 1 minus, right? It's just equal to 2 times, and now I do t dot inv, and I'm sorry, t dot dist. T dot inv is when we're doing the confidence interval, right? Okay, degrees of freedom. I have a combined 17 degrees of freedom. It is cumulative. And it's going to be quite large, actually. And it is. Okay. And let's round these numbers down because they're a little unwieldy. Okay. All right. So now we can look at this, and again, the same sort of conclusion, right? Our decision rule is going to be applied. It's going to be the same sort of thing. Let me just increase this a little length of it. Even though p is not as large, it's still 0.51, which is a lot larger than 0.05. So we're going to fail to reject a null hypothesis. So we would say that at a significance level of 0.05, there is not enough sufficient evidence to conclude that the average battery lifetimes of the 2 different types of tablets are different. Okay, and that's pretty much all for that problem. At least part A. Now we need to do part C, okay? And again, B is the same thing. You know, we computed the p-value. The reason why they're having you do this is they're actually doing a different way of doing the hypothesis test using a critical value, which I didn't teach you. So this is if you had done it the critical value way, you'd still want to compute the p-value. But we've already done this part. Okay, so assuming again that all these variances are the same, we want to construct a 95% confidence interval. This is pretty easy. The same, in fact, it's really the same sort of thing we did last time, right? So for part C, the first thing I need is the confidence. So we're going to construct a 95% confidence interval for mu1 minus mu2. Okay, so first I'm going to write the confidence. I'll do this a little and a little more detail this time. Okay, so the confidence here is 95%. So this is going to be equal to 1 minus the confidence. And now I need my critical value. So now this is basically the value corresponding to the alpha over 2 percentile for a random variable coming from a t-distribution with 17 degrees of freedom. So now we're ready for the critical value. So now we use t.inf. Whoops. That's what I want. And divide that by 2. And I have 17 degrees of freedom, but I'll go up and click on the right one. And that's it. That's it. And again, it'll be negative, which is okay. The margin of error is just going to be equal to this critical value times the standard deviation of x1 bar minus x2 bar, which we found was this. And now we're ready for the upper and lower endpoints. I'll do the lower first. Okay, so this will be equal to, and notice that you can still see in the formula bar what's going on. Okay, it's always a nice little feature. Minus the margin of error. Okay, and for the upper, I'm just going to cut and paste this, then hit enter, go to the next line, change that negative to a plus. And we can see that 0 is in there. Is that a surprise? No, we know that has to be the case. So 0 has to be in the confidence interval because we failed to reject the null hypothesis at the alpha that when added to the 95% confidence gave us 100. That 0 is not, that the difference was not equal to 0. Okay, so again, at alpha equal to 0.05, let me go back there for a second. So when alpha is equal to 0.05, we fail to reject the null hypothesis that the difference was equal to 0. Therefore, at a 95% confidence interval, 0 has to be in it. And we see that it is. Okay.